Hey everyone, you're joining Miss Danica and Miss Carrie from Henry County Conservation as we learn about some of Earth's most incredible forces of nature, earthquakes and volcanoes.
First, let's start with earthquakes. Miss Danica, do you know where most earthquakes occur?
I can't say that I do.
Well then, take a look at this map. It shows us where every earthquake with a magnitude of 8 or higher that happened between the years of 1905 and 2019.
What's a magnitude?
It's what scientists use to measure the size of an earthquake. The shaking is recorded with a machine called a seismograph. This is a model of a seismograph. And so what you need to do is there would be a needle that goes up and down on this roller in the middle. So we're going to just use this pen, and then I'm going to manually use the roller. And while I do that, then I'm going to shake the table and make the earthquake. When the earth shakes, the needle of the seismograph moves up and down depending how intense the shaking is. An earthquake's magnitude increases as its intensity increases. So for example, a tiny earthquake would be a magnitude of 1 and the needle would just barely move. People don't feel anything when it's this small. A huge earthquake would be a magnitude of 10 and the needle on here would be going crazy up and down in these big spikes. These are so intense that people thousands of miles away can be affected. Take a look at the damage caused by this 9.5 magnitude earthquake that happened in Chile in 1960. It is the largest ever recorded in human history. Now, it was so big that it created a tsunami that damaged places like California, Japan, and even the Philippines.
Wow, that's incredible and a little scary. Hey, I noticed something earlier that I thought was kind of weird. All the earthquakes on your map seem to be in the same places. Miss Carrie, why is that?
Great question, Miss Danica. To answer that, let me show you another map. This one still shows the earthquakes from the last map, but it also has some red lines drawn on it. What do you notice about where the red lines are and where the earthquakes are?
The earthquakes seem to be found wherever the red lines are. So, what are the red lines?
They're tectonic plates, of course. The outer layer of the earth, called the crust, is made of giant slabs of rock called tectonic plates. Those plates fit together like a giant jigsaw puzzle, and they're constantly moving. Because of that, natural disasters like earthquakes can occur. As the plates move, their edges get stuck due to friction. When the amount of stress overcomes the amount of friction, there's an earthquake that releases energy waves which travel through the Earth's crust and causes the shaking that we feel.
Well, what happens to buildings when all this shaking happens?
Let's find out. Here's some building blocks. You have some and I have some. Let's work together and build a building. All right, here comes the earthquake.
Oh man. Wow, our building is destroyed. Is there anything we can do to prevent that from happening?
Unfortunately, earthquakes are going to happen whether we want them to or not. But there are some things humans can do to reduce the impact they have on our lives. Why doesn't everyone pause the video here and write down ways that you think humans can do this? When you're finished, click play.
Okay, let's see how you did. Miss Carrie, what can we do to reduce an earthquake's impact on us?
Well, we can identify potential hazards around us, like falling debris, and then move away from it. The best thing you can do is use your brain. Educate yourself about earthquake safety procedures.
What about the buildings? Ours didn't stand a chance. What if I could anchor my building to the ground and reinforce it to stop it from falling and moving around?
Well, that's a great idea, and it should be used. But remember, your building is probably still going to have some damage, because when it comes to earthquakes, there is never 100% certainty.
You know, while I was looking at your map, it reminded me of another map I've seen.
Oh, really? And what map was that?
Well, I was plotting the locations of different volcanoes that erupted over the past 300 years on a map that was separated into 4 quadrants. Asia, North America, South America, and Australia and nearby islands.
I don't understand. It looks like a bunch of random triangles.
Well, each triangle represents a volcano. Separately, these maps are kind of hard to read, but once I put them all together...
Wait a minute. That looks like my map.
Volcanoes and earthquakes occur in the same place. The reason? Tectonic plates. Areas where the plates sink below another allows magma to escape the mantle and form volcanoes. The ring of volcanoes you see on my map is called the Ring of Fire. Miss Carrie, did you know that volcanoes come in all shapes and sizes?
Well, I knew there were different shapes, but I don't know why.
Well, let's find out. First, we need to take a closer look at the lava that's inside these volcanoes. Lava can be either thick or thin. So, to demonstrate, I have 2 containers. One has thin lava, and the other has thick lava. Miss Carrie, I want you to take this straw and blow bubbles into the thin lava. Were you able to blow a lot of bubbles or just one?
A lot.
And was it easy or hard to blow those bubbles?
It was really easy.
Perfect. I'm going to set this one aside for now. But, kids, I want you to remember what happened. Next, I want you to try blowing bubbles into the thick lava. Okay, this time, were you able to blow a lot of bubbles or just one?
Just one really big bubble.
And was it easy or hard to blow this bubble?
Well, it was hard. And it took me a while before it finally exploded into that one big bubble.
Great! Kids, remember what happened. Next, let's see what happens when we pour the lava out. I'll start with the thin lava. Did the thin lava form a mountain or volcano shape?
Nope. It just spread out.
Okay, well, let's try it again, but this time let's use the thick lava.
Wow, look. This time it's piling up on top of itself and kind of even making a volcano shape.
That's right. There are 2 main forms of volcanoes. A shield volcano and a cone volcano. What kind of volcano do you think thin lava makes, and what kind do you think thick lava makes? Pause the video now and write down your answers. When you are done, play the video. Let's find out what kind of eruption will happen. Miss Carrie is behind the model of a shield volcano. Let's see what kind of eruption it has.
Wow, that's so cool! Looks like a slow and steady eruption to me.
I agree. Now let's see what kind of explosion a cone volcano has.
Oh, I would definitely say that is an explosive volcano. But Miss Danica, how does the type of lava fit into all of this?
I'm so glad you asked. Think about what happened when you blew the bubbles. We already know that thin lava comes from shield volcanoes, but the reason its explosion was flowing and steady is because thin lava allows gas bubbles to pass through and be released into the atmosphere easily. On the other hand, cone volcano has thick lava inside. Because the lava is so thick, those same gas bubbles can't get through, so they are trapped and keep building as more bubbles try to escape. When the pressure of those bubbles becomes too great, boom! Explosion.
Now this is really cool to learn about, but I'm also a little nervous. I really don't want a volcano to explode where I am.
Well, luckily Iowa doesn't have any volcanoes, but there are places we may travel to that do. Unfortunately, there's nothing we can do to stop a volcano from erupting, but there are some things we can do to reduce the impact that they have on our lives. Volcanoes often give warning signs that they are about to erupt, like smoke, which gives you plenty of time to get out of the way. Make sure you pay attention to government evacuation orders. If they tell you to evacuate, do it. Don't stay behind and hope the lava misses you. And lastly, always be prepared with an emergency bag.
I feel better already. Thanks for watching, everyone.
Bye.